Hello, my name is Sels, and I have built a LinkedIn web scraper using Python. In this video I will be explaining how this code works in detail. Obviously all this code is available on my GitHub, which there will be a link for in the description. Before I explain how this code works, it's probably best to show you the web scraper in action. It opens LinkedIn. It goes through each job. It fetches each job, in this case from Belgium and Netherlands, from the past 24 hours, any experience level, and workplace type, remote and hybrid. Once the web scraper is done, it will save these to a CSV file right here, and send me an email with the scraped jobs. Here is the email I have received, with a title, the date, and all the scraped jobs. If I click on any of these links, it will bring me to the right job. Okay, let's go into detail on how this code actually works. Future me sliding in here. At first I built a web scraper for the job searching site Indeed, and it worked fine until the site changed its bot protection overnight, I'm assuming. That forced me to switch and alter my scraper script to work for LinkedIn instead. As for the CSV file that the scraper outputs, on its own this data might look only moderately useful, but when you combine that CSV with AI or machine learning tools, you can do lots of things. For example, from a job matching agent to tools that spot new trends before others can. Obviously these are just two examples, the possibilities are endless. Anyway, carrying on. Obviously we have a bunch of imports, these will make sense as we go through the code. A load.env, which I'll explain in just a minute. These are variables. The first one being job keyword, junior developer is the type of job we are looking for. Then countries, this is the location, in this case I've made a list of Belgium and Netherlands, we will be looping through this list later in the code. Date posted is 24 hours, here we can see what options we have. Experience levels is currently an empty list, meaning all levels are selected. Workplace types is also a list, in this case we have 2 and 3 which link up to remote and hybrid. As we go down we have more variables, sender email, email password and receiver email. This is where the .env comes from, this is to add an extra layer of security. My .env file is right here. All of these should be equal to something in between quotations. Sender email and receiver email are pretty self-explanatory. The email password is a 16-character long password, which is the Google app password, and it should come in a format like this. You want to make sure you remove the spaces and paste it in the appropriate place. I just want to clarify that your Google app password is not your actual email password. This is a 16-digit passcode that grants a less secure app or device permission to access a Google account, but only if you have two-step verification enabled. Okay, let's move on. These variables will make sense in just a minute. Then we have safe file names. The word safe is just a Python naming convention. This signifies that your code has been cleaned and processed. So, for example, this can be done by replacing spaces with underscores so it doesn't break anything. In this case, the job keyword has its space replaced with an underscore. Now I could manually do this myself, but this just adds an extra layer of validation. With experience, a similar thing happens, but firstly they get joined together using a comma, before then having their comma replaced with an underscore. Now I've just realized that this is a bit redundant, I could have just joined them together with an underscore, but it's fine. If the experience levels list is empty, then it will automatically be set to all. A very similar thing happens for the safe workplace, and for the safe date, nothing really gets changed. Setup Chrome, these are different Chrome options we can change, such as add argument start maximized, which has the screen pop up maximized when we run the scraper. We've got incognito as well, and we could for example add headless, which prevents the screen from showing, but obviously for demonstration purposes I will keep that off. Then we have the driver. This creates a new Chrome browser controlled by Selenium. All of these are from the Selenium library, with custom settings I specified in the options. Alright, here we have the first function, with a bunch of parameters that will make sense as we go through this. The first variable is the experience parameter, which once again is being joined with a comma. If there are no experience levels, then it will just be empty and nothing will get filled into the URL for that. The variable workplace parameter is very similar. Date parameter starts off as empty, and if the user chose 24 hours, a week, or a month, it will take on the corresponding code right here. I've chosen this method because otherwise, it wouldn't be very easy to remember these numbers right here. Then we start building the URL. We obviously have LinkedIn, job, search, keywords. Then we have quote plus. This comes from the urllib.parse library right here. What this does is it turns the keyword into a URL safe format. The same goes with location. Then if the experience parameter exists, it will add that to the URL as well. The same goes with workplace and the same goes with date parameter. Then at the very end, it will add URL position is equal to 1 and page num is equal to 0. This can be seen right here. The position is actually what card we are on. Currently we are viewing the first card. If we go to the second, we will be viewing the second card. Third is third card, fourth is fourth, and so on. The page number is pretty self-explanatory. It's whatever page we're on. Once it's gone through all of this, it will return the URL. Scroll page is the first function we come across. Attempt is set to 0. Last height is equal to driver.executeScript. ExecuteScript comes from the Selenium library. In this case, we are executing some JavaScript code called return document.body.scrollHeight. This is essentially the max height of the page currently. While attempt is less than max scroll attempts, which is set to 200, it will loop through this. Driver execute script once again, Windows scroll 2, so this time it will scroll. 0 is the X value, document.body.scrollHeight is the Y value, so it will scroll down to the maximum scroll height. It will then sleep for scroll pause, which is 5 seconds. Then it'll try to find the show more button. The show more button shows up on the page once you've scrolled down far enough. It will repeatedly check for the next 5 seconds whether there is an element with the expected condition. In our case, this is class name infinite scroller show more button. And once that condition is met, it will return that element. Once again, there is a sleep of scroll pause, 5 seconds. It will try doing this, but if it fails, it goes into accept and passes this. The new height will be set to the new max page height. Obviously, if new height and last height is the same, it will break out of this. But if new height and last height differ, then the last height will be set to the new height and attempt will be incremented by 1. It will keep looping through this until max scroll attempts has been reached, or it breaks out of this. The next function is fetch job details. Job description and company description are set to empty strings for now. If there is no job URL, then it will just return the job and company descriptions. Then it will try to get the job URL. This is Selenium opening the job URL in a browser. Then a very similar function to the one we saw before, but in this case class name is equal to description text. Job soup is another variable. Beautiful soup is another library we've imported, and page source is the raw HTML data. Beautiful soup parses this raw HTML data. Parsing basically means analyzing some data, like text or HTML, and breaking it down into a structured format that your program can more easily understand and work with. Job div coming from the div tag right here. Find pretty much lets us query through that parse data from before. In this case, we are trying to find a div with the class name description text. Job description is very similar, but in this case we are getting text. The separator \n just means we add a new line for every new element we come across. I can actually show this. Here is the description and here is the class name that we previously mentioned in their code. If we open up this div, you can see that there are multiple different tags such as strong, break, strong, ul, li. Every single time we go to a new element, it will add a new line in between those. Strip is equal to true removes the leading and trailing white space around it. Obviously, if there is nothing in job div, we will leave it empty. Company div is the same as job div, but we're just looking up a different class. Then company description is the same as job description, but we're using company div instead. If an error arises, it will print out that error for us. Then it will return the job description and company description. Send job email. Obviously, if there are no jobs, then there is no email to send, so return false. Jobs_HTML is set to an empty string for now. Then it will go through each job in the jobs that we have and create a custom little stylized HTML card. This was generated using AI, it isn't anything fancy, it's just to make it look a bit more appealing. HTML content is what will be sent to the email. We have a very simple header with the amount of jobs found, a date, and then the job card. Each job card will be put underneath each other. Then at the end we have an automated scraper message with a more precise time. EM just stands for emphasis, which means it'll put this in italics. Then we will create the message. MIME multipart is another library. In this case it creates a new email message object that can hold multiple parts like HTML, plain text, or attachments. We obviously have from, which is a sender, to, which is a receiver, and subject, a simple subject right here. In this, MIME text is letting the email client know how to render it. In this case we have HTML content here, and HTML is the type. In our case, instead of plain text, it's HTML text. SMTP-lib is another library. This opens a connection to the Gmail's SMTP server, which is the service that sends the email. 587 is the port commonly used for SMTP. As server, which is just a name. Start TLS upgrades the connection to a secure and encrypted one. Server.login is pretty self-explanatory. It logs into the Gmail SMTP server with the sender's email address and its password. Then send message sends the actual message over. We've got a quick print message here which tells us that the email has been successfully sent to the receiver, and then return true. If there is an error, then it will print that error and return false. Here comes the actual scraper. All jobs is set to an empty list for now. For country and countries loops through all the countries I have listed. Where is it? Right here. It will print out which country we're currently at, and it will grab the URL from this function we talked about earlier, then also print it out and search it up. Scroll page is the other function we built. HTML grabs the raw HTML data from the page. Soup once again parses it, and job cards finds all the cards, or in divs in this case, with the class name base card. This will go through each card in the job cards we found earlier using an index. Firstly, we find the A tag using this class right here. Job URL then uses that A tag but takes specifically the href from it. Strip means it removes all the white space around it. Job title does the same, but with the span in this case. Company tag in this case finds the h4 with this class, and company A takes that company tag and takes specifically the anchor of it. All of the remaining ones pretty much use the same method. For each of these, it then tells us which index we're on out of the amount of job cards we have, and prints out that title as well. We then take job description and company description from the tuple the fetch job details returned. All jobs is the empty list we saw earlier, and append is a list method that adds one item to the end of the list. It will append this dictionary of information each time for each job card. Now that we have all jobs in a list, we can use this to create a CSV file. CSV stands for comma separated values. It's a very simple way to store table-like data in a text file. If there are jobs, then it will create a file name right here. What this does is it takes all my countries from the list and joins them together using an underscore. If you have Belgium and Netherlands, it would be Belgium _ Netherlands. But obviously if you had a country like New Zealand, New and Zealand has a space in between it, which is what this is for. This removes that space. With and open creates and writes, which is what the W stands for, our CSV file with this name right here. New line we previously saw had a \n inside of it to create a new line. In this case I've left that blank. And encoding UTF-8 is just a very common encoding standard that supports pretty much all characters in all languages. Dot keys, as you see right here, are all of these values. This will be used as the very first line, the header, in order to identify what is what. Then write rows writes all the remaining rows for all the jobs that we have. It will print that these jobs have been saved to a CSV file. Obviously, if there is an error, it will say that no jobs have been extracted. Lastly, it sends the email using the send_job email function, and once all of that is done, it quits. Once again, this code is available on my GitHub, which will be linked in the description, along with a link to my Gumroad if you wish to support me or buy a 3D model. Thank you for watching. See ya!